the extra help. So first things first, assessment changes. Assessment changes. We need to recognize that. Hey, Isaiah's here. Okay, I'll look for it. Assessment changes. I plan on having a test tomorrow. What we're going to do instead is this. We're going to do a demonstrate understanding tomorrow on logarithms and inverses together. And so what I'm going to do as a result is there's going to be a test on Thursday for those who are likely to exempt, okay? If you're not exempt, or you already know, hey, I'm probably not going to be exempt for this reason or that, there will be a mandatory part of the final that is on logarithms and inverses. The rest of the final will be very similar to the midterm, where you show me evidence of understanding with things that you did not earlier in the year. That will cover linear, exponential, quadratic functions from Unit 2. It will cover solving quadratics from Unit 3. And it will cover polynomials from Unit 4. And then there's a mandatory inverses and logarithms. So, again, if you think you're going to be exempt, you'll take the test on logarithms on Thursday. And we'll be going over the demonstrate understanding before the test. Questions about that assessment moving forward?
We're going to finish our amount today.
Today/tomorrow morning. Yeah. Like, all the new stuff you need should be done today, and practice/review tomorrow before the demonstrate your understanding. Yep. So then today, logarithms as inverses of exponentials and evaluating logarithms. Okay, so if the inverse of 3, what does this say? What does it say? Chandler, what were you doing? What were you saying right here?
That's not me.
Who is this though? I just don't know what's being written here. If you can clarify it, let me know so I can.
It's like inverse of 3 is negative 3. So it's like
Is negative 3. So be careful with that language. Which inverse of 3 is negative 3? What type of inverse are we talking about there?
Opposite.
Opposite, right? That's known as the additive inverse. So right here, hey, listen, what would an exponential version of 3 be? Well, that's not a logarithm, it's not an exponential. Like, what is a way that I could rewrite, or I could use a 3 in an exponential expression? 3 to the power of x, or let's make it a little bit easier for us, 3 to the power of 4. This is what we're going to focus on most of today, but engage in this to help build that foundation. 3 to the 4th power will be 81. That's an exponential with the value out here to the side. So, when I'm talking about a logarithmic inverse of that, first off, what is the inverse of an exponential? What do I need to write first? Log, right? So I'm going to write log. And the base of the logarithm needs to be the same as the base of the exponential. What's the base of my exponential? 3. So it's going to be log base 3. Notice I wrote it as a subscript. And then with inverses, what's the foundation? What's the key small detail for all inverses? Can't just say the opposite. There's another word for it. So what's transposing? So inputs and outputs. Notice I'm saying that, and the reason I've always said that is, are there x's and y's here? No. What's my input? 3 is my base. It's an exponential. Remember, the exponent is my input for an exponential. So the input is 4. The output is 81. So what was my input is going to become my output. What was the output becomes the input. So when I say that, I'm looking at log base 3 of 81. And what I'm asking then, or what would log base 3 of 81 equal? 4. So what is a logarithm really? A logarithm is just the
Inputs and outputs.
yes, but think about it. What it was in the original equation. What are we going to call this right here?
Power.
Not just that. It's, closer. I heard someone say power. It's not the power. It's the exponent. So just to clarify, I didn't know this, I'll go ahead and tell you, until about 2 or 3 years ago. It is a base 3. It's an exponent of 4. And the entire thing is known as a power. So the power is not 4, it is 3 to the 4th power with an exponent of 4. So that's the difference in that language there. So what is a logarithm? Like when I evaluate a logarithm, what's it always going to equal? Well, not always a 4, it's always the exponent, right. If I were to look at log base 3 of 27, I am asking,
So basically, you can just do 27 divided by 3 and you get your exponent.
you think so? Is 81 divided by 3 4?
No, you have to find your power.
You have to find your power, well you have to find your exponent, right? Does anyone know what exponent could go on 3 to give me 27? Because that's what I'm asking.
3, right?
3 times 3 is 9 times 3 again is, so how many times did I multiply? 3? 3 times. That's all a logarithm is. It's asking for the what?
Exponent.
Exponent.
That's
Yes.
what we gotta do is find it.
That's, and
That's
that,
a catch for that.
that's it. No, like legitimately, okay? That is what a logarithm is. We can go into properties of logarithms, which we won't technically have time for. Right, Kyson? Sean? What did I just say?
That exponent
What did I say after that?
after that.
Yeah.
Oh, I don't know after that.
Yeah, because we're talking and
I
not
was
listening. Come on. There are more things that we can go into. They're called properties to help us solve equations. But if you understand that a logarithm is just an exponent, all of it makes sense. We're going to just focus
That's what we're
on.
gonna find out in 10
There's one other thing we're going to do with that. Hey, guys. In a second, if we can't stop talking and standing in the back, you're going to walk up here and be right next to me so that we can focus. Thank you. Yes, Chandler. Well, what an exponent is how many times you're multiplying that base. So when I say 3 to the 4th, say again. Well, the logarithm is equal to an exponent, right? That's the exponent. Base 3 to the 3rd is equal to 27. Base 3 to the 4th is equal to 80. That's what I'm saying. The logarithm is equal to an exponent.
Rick and Morty over
Yeah.
there, like Rick.
All right, council, please move up here for me. Thank you. So, how do I solve a logarithmic equation? So, or an exponential equation? So, if I were to have 3 to the, let's say x is equal to 243, okay? Notice, I can't take a square root because it is not being what? Squared. I can't take a 4th root, a 5th root, a cube root, because it's not being raised to a power. But we just discussed this. What's the inverse of an exponential? A logarithm. So you know what I'm going to do to both sides of this equation?
Logarithm.
Now remember, division is the inverse of multiplication. What is the inverse of an exponential? So what am I going to do to both sides? I'm going to do a logarithm. And we're going to talk more about this later. But which base does this logarithm need? Base 3. And so when we do a logarithm, what I'm asking is what exponent goes on the base to give me, and this is called an argument, that's just the name of it. So literally, because they have the same base, what is the exponent?
3.
What is the exponent?
27.
Again, what is my exponent?
8.
There we go, the exponent is x. Notice these are inverses, so they cancel. And so then, right here, I'm asking for an exponent, right? Does anyone know what exponent goes on 3 to give me 243?
6.
You think so?
No.
So everybody grab a calculator, let's find out.
19.
Come on, tonight, calculator in hand. Amari, go grab a calculator. Simone, help Amari out. Please don't fold that up, you need that to study, Amari. Huh? I'm just looking out for you, girl. Okay.
Y'all, can you give me a calculator?
No.
Turn off.
Miss King, you finna show us how to do logarithms?
Hey, if you in the camera,
Yes, sir.
you in the camera, touch it, twin. Get out the camera.
So,
Hey, Mr. Kim, can you delete that video and restart?
no, ma'am.
You cool.
So, well, I can't.
She
Call
was
walk.
like, she was like all up in it, basically.
It's fine.
My calculator.
You finna post it on YouTube. I'm finna record
It's
it.
gonna be okay.
No, it ain't.
So,
Be on there no more.
ladies and Chandler, do you have a calculator?
YouTube.
Hey, Cam, can you grab a calculator for Chandler, Trey, Arion? Y'all got calculators?
Oh, no, they gonna get that calculator. They can't.
Jaden, you got a calculator?
Oh, God, they going
Yeah, they going
Thanks for grabbing the calculator, Trey. Alright, so when I look at a calculator page, okay, where is the exponent symbol on the calculator?
next to X squared.
So
It's the razor
now
bar.
notice- Hold on.
It's the razor bar.
Hold on. So this is x squared. This is raised to a power. But when I talk about an exponential, I don't want a power. Remember, my exponent's going to be a what? An x, a variable, right? Look below that raised to symbol. What's below there? What does it say? In black, it's e to the
That red
x.
thing.
What's next to
That
it?
red thing.
10 to the x, right? So, excuse me, Arion, I'm teaching, all the guys in the back. I'm tired of this. Like, we gotta learn something. Whoever, so if it wasn't you, KK, my bad. But I'm talking about, like, we are constantly hiding in the back trying to talk while I'm trying to teach you. I'm done. It's been 17 weeks where I've tried to help you learn something. Focus and try to learn something. So, notice what is right above those exponential expressions, those variables in the exponent. In blue, sorry. It says ln, we'll talk about that later, but it says log right next to it in blue, right? So, or y'all's is in gray. So hit control and hit 10 to the x. So control,
Hit the X.
and then that 10 to the x, notice what does it give me? So, but notice it gives me a logarithm, right?
I can't do 10 to X.
I was just wondering.
Guessing.
No, it's not. What's my base?
3,
3. What's my argument?
8, 3.
243. Type in 3 and 243 in.
You gonna get 3.
Like I said, it's better than guessing. 'Cause like, I
It
was
is
going
better
to-
than
I was
guessing.
going- I was just guessing.
How I do that walk?
Hey, I need help.
Okay?
5.
I need help.
Oh, you got control.
Control
5 point.
Control 10.
So,
Point.
Listen, look at that right there.
Mason
Control.
pointed out, and what we all need to recognize here is, you could just guess and check. And sometimes it won't always work like this.
5.
But, hold on, listen. Sometimes you can guess and check, but that's not always going to be the best option. Yes, Sean, what about it? Yeah, thank you. Yep. And so, if I guess and check, right, I could do 3 to the 4th, 3 to the 5th, 3 to the 6th, and notice 3 to the 5th is equal to 243. That's what the calculator just told us, that exponent. What you doing, dude? Get your stuff together right now. Eric, Dewan, if we were seated, that couldn't have been a thing. Eric,
I'm trying
I
to
need
grab
you
my
seated
stuff.
right up here.
Cool, I ain't even do that. I was trying to grab my stuff, my fault. I ain't do that. Slipper shit. He tried to run me over too.
Arion, for your sake and my sanity, please take a seat. Thank you, sir.
No,
So, say again. I made it up. Not random. I knew 3 to the 5th was 243. So I chose to do that. Okay. So, Cam, did you get it?
Get what?
The 5. Salt, did you?
Yeah.
Okay. So, notice though, okay, if I were to give you 3 to the x equals 600, okay? 3 to the 5th was 243. 3 to the 6th is going to be, can someone type in 3 to the 6th for me?
I got you.
It's going to be 729, I think. 729. So notice Is that gonna give me a nice integer exponent?
Oh.
Is that possible to solve by just guessing and checking? So how would I need to go about solving this equation? I'm gonna take a log of both sides. What is the base of this logarithm?
3.
Log base 3. And so the beauty of this is, once again, these are inverses, so they're going to cancel out. I'm literally asking what's the exponent. Well, I'm left with x as my exponent. And what's log base 3 of 600?
5.8.
Does anyone know what kind of number this is going to be if that decimal just kind of keeps going and it doesn't repeat? It is, well, it's not repeated. If you look again, it's not repeated. It's going to be what? It's going to be an irrational number, okay? But please notice, hey, right here. So please notice, like, you would have never been able to accurately just guess it. You could have gotten close, but it would have taken a lot of guess and check. But at the end of the day, Dewan, what is a logarithm? It's an
Oh no.
Chandler, can you help Dewan out? Close. It is the inverse of an exponential, but what are we getting? When I get this 5.82, what is that? That's the
answer.
It's the exponent. Can't just say the answer. Your answer can be wrong. It is the solution to that equation, but what is the solution? It is an exponent. When I ask you to evaluate a logarithm, when you calculate a logarithm, what are you always calculating?
The exponent.
The exponent. Okay? Some of us are asking about domain and range. Logarithms can only be used for exponentials. There are some other cases where we can apply them, but I'm not going to assess you on them. How do you graph a logarithmic function? We'll talk about that again in a second. The exponential reflection. So I'm going to tie several of these things together. Okay.
You don't gotta worry about it.
Yeah, I do. Alright, so I'm going to talk about this one right here, and I need y'all to engage in this conversation because it's going to answer several of these other questions. So, if I were to give you y equals, let's go with 2, this is going to be easy. Let's actually go with 1/2. To the x minus 1 plus 3. Okay? This, let's do this. I want you to get your Frere model out, and let's put this example where it says inverses of an exponential function. We can use it then to do features of a logarithmic versus exponential function.
Wait, what did he say?
So the Frere models,
Frere model.
okay? You will also want your proficiency scales for later.
Or not?
Okay, no worries.
So you want your logarithms and log functions and Frere model. Your notes to your future forgetful self. Come on, Amari.
I don't know where it is.
So then if I didn't say something, you would have just sat there this entire time, not asking for one and not being able to take notice. And if I was going to let you do, which I haven't decided if I'm going to, but if I was going to let you use your notes for your demonstrated understanding, you'd be up for free, right? Yeah, let's fix that.
So we're gonna do Friday. You're taking it.
Review for our final. You know there's about the same ones, right? I will give those back tomorrow. Not the other test, not the test that we just took. Anybody else need a prayer model? Guys, we gotta hold on to our resources. No, I gave you a new one of this.
I ain't get out.
Give it to y'all Friday. Alright. We're on, listen, what we're about to do is an example for inverses of an exponential function. So which quadrant are we looking at? Which section? No, ma'am. Bottom left. Inverses of an exponential function. And we're going to use that for the features. We're about to do this problem. Okay? So, under inverse of an exponential function, start here. And I'm going to give you the background. I'll give you the exponential part right now, and I'll tell you what the values are. And it's going to answer a lot of the questions people are asking. So actually, let me write it here. We'll do exponential here. actually let's call this g of x equals 1/2 to the x minus 1 plus 3. Okay? So, looking at this function, there's a couple of things I want to point out. First off, KK, would this be an exponential growth or decay?
Okay.
Decay, does anyone want to, let me do it this way. Does anyone want to add on to, meaning giving a reason why you agree, or push back on it being a decay? You agree? What's your reason for agreeing? Notice, what are we referring to? What's my base? 1/2. What else can I call this base? That's the, that's my constant factor, right?
Which is not gonna change.
That 1/2 is what I'm repeatedly multiplying by. It's got a variable exponent. So at some level, we're repeatedly multiplying by what? 1/2, right? Yes, Chandler.
Is it y equals or is it g?
So remember, this is known as my function notation, where my input is x and my output is, but right here's g of x, but in general the output is also called y. So you can use y or g of x. I'm using g of x to have that function notation. We're going to want that in a second. Alright, if I were to talk about this, and this is not what I'm assessing you on, but I want us to make this connection. If I was to talk about, what type of function is up here? Vertex form. What are h and k again? The vertex, right? And it translates the parabola horizontally by h, and it translates it vertically by k. And we haven't talked a lot about transformations. I'm not assessing you on this, but does anyone know what transformations we have in this from the original 1/2 to the x? That's the parent function, the base function. What transformations would this have? So the x minus 1 would do what? It would translate it to the... Well, it's not a reflection, right? It's a translation. So that shifts it, moves it up and down, left or right, one of those two. So let's think about it this way. I'm going to equate it to this. What would that minus 1 do in that parabola? Would it be minus 1?
It'd be add 1.
I would say everything with that x, right? All of those horizontal were acting the... Starts with an O? Opposite, wasn't it? And so instead of the h being a -1, the h would have been a positive 1, with the k would be a positive 3. To get to a positive 1, it had to shift to the right one and
Up
3, right? You see that now? Right? Had to be to the right one and up 3. So we're not, again, I'm not assessing you on this, but it'll help if you see this in a future class. This function would be translated to the, what's that going to do? Remember, what happened here is to the, that didn't move it to the left, it moved it to the,
Right.
but how is this different?
First one's in parentheses.
But it's still x minus 1, isn't it?
It's x divided 2.
It's to the parentheses. Right.
Okay, what do parentheses do, guys? They just
Separate.
they actually group, right? Which does separate from other things, but they group. Are these grouped together? It's grouped together in the exponent.
Yeah.
So the transformations here are the same as the transformations here. This is still a translation right by how much? 1 and
Up 3.
I need you to notice it hasn't changed. No, I'm just emphasizing and pointing out, I'm about to get to this over here right now. I just want us to see the connections between this form and our vertex form because it's acting exactly the same. Remember, everything horizontal acted the, Des said it earlier, the opposite, right? Everything horizontal acted the opposite. So be to the right one and up 3. But here's what, the reason why I say that is, this is how I know what to do for my table. Normally, we do -2, -1, 0, 1, 2. But what do we just say is happening horizontally, happening to the x? It's translating to the right one. So what I'm doing for this table, and this is where you want to start writing this down, I'm going to add 1. I'm going to translate all this to the right one. So -1, 0, 1, 2, 3. I just translated all those x values to the right one. I'm not going to expect you to do that. I will give you the table, but for anyone who's like, well, Mr. Kenny, how do you come up with these numbers? That's how I came up with these numbers. Yes, Chandler.
Why is it like there's a negative?
Because remember, Chandler, everything acts the opposite. We've done this since first 9 weeks. Remember, if it's x minus 1, just like it's x minus h, the h is a, I just erased it, but a positive one. Everything horizontal acts the opposite of the way it appears. Every time.
Within the factor.
We did with the vertex form of quadratic. So the way I get my outputs is I just substitute my inputs in. So let's do this. Group 1, I want you to substitute -1 into this expression. Group 2, you're substituting 0 in. Group 3, you're substituting 1 in. Group 4, you're substituting 2 in. Group 5, you're substituting 3 in. Group 7, you're substituting the -1 in. Group 8, 0. And group 9, 1. So everybody pick up a calculator in each of those groups and type that in. So notice, just put it, substitute -1 in for x, a 0 in for x, positive 3 in for x. Be careful with what you get.
So we put it, what an x is? X minus 1?
Yes, these are my x values.
7.
No. There's no logarithm here. Just type that in. 1/2 to that power. 7.
Oh, you mean right? Who did 0?
I did. Is that what you got? Okay.
Oh, I was going to do it.
I'm trying to get y'all to check and make sure you understand how to do this.
Do I put a parentheses around it?
I would tell, make sure you don't make a mistake. So check to make sure you're able to get those correct values. Or it helps pick up a calculator. Try typing it in.
I got it.
Kyson, you told me you were capable of more. I want to see it. Okay, is that what I got? You got 7, is that what you got? Then you're just typing in the expression and substituting your x in. So 1/2.
Be smart.
You can't be smart, but you can learn. You always learn. The one you actually learn how to do this? That's yours that you already did? Yes, talk with each other, help each other learn it.
First though.
Julie,
X minus 1. X minus 1.
come here. You didn't want to help them type it in or not do it for them, but look. It's a 1/2, right? You see that? And then I have an x minus 1. The x minus 1, that's what Sean's trying to point out. What fun was like doing x minus 1? That's only a square. So you're going to add the x minus 1. And your x is -3 minus 1.
Don't do minus negative.
You're substituting your x in. What was your x? So you didn't, no. Your x is so remember.
It did.
All you did is
I did it.
Alright,
I didn't put it in.
so right here, once I have these points, I can graph them. And so you're only going to want one graph, but be careful. Make sure you do a nice even interval. Notice how I'm trying to do the same distance every time here. Yes, ma'am. So you have not written those points down for the table, go ahead and do that.
Oh, you want us to plot those points?
And then create a graph to plot those points. If you need a sheet of graph paper, let me know, because I know it can be helpful.
Graph paper.
Yes. Graph paper with grid,
No.
so.
The one said is negative.
Anybody else need a sheet of graph paper to make sure their graph is pretty accurate?
We got a graph.
We're gonna graph in just a second. To answer these questions about logarithms and all those things, yeah, we gotta graph it.
You ain't saying.
Well, that's why we did a positive.
-1, -1.
Positive, because it's horizontal, we use the opposite of that
You
minus.
said
There
negative
you go, that's,
1.
you need one too, guys? Do any of y'all need a sheet of graph paper?
Two -1, and he seven. Y'all just move them.
Okay,
You go. Oh, thank you, my brother.
if you're going to use this, you know, if you're gonna use this graph paper, if you're gonna use this graph paper, you need to make sure you make a note to yourself. Hey, Jacqueline, am I teaching? Am I talking? Thank you.
We make sure your flow it don't
Go
have
on.
ants on it.
Hey, listen, we'll take care of it later.
He critical.
Hey, go on. Go on. If you're running your mouth, you can't hear, and I need you to learn this. So, if you're using this graph paper, what I need you to do is make a note to yourself that your graph is on this graph paper. In fact, if you want, you can put your notes on here to help, but make sure you make that note to yourself. Now, all you have to do at this point is graph. Be careful with your points, though. Be careful with your points. Graph the points that are here for g of x. So -1, 1, 2, 3, 4, 5, 6, 7.
Oh my God.
Okay? So -1, 7. 0, 1, 2, 3, 4, 5. 1, 1, 2, 3, 4. Now notice I'm going to use the decimal version to help me approximate this one. So 2, 1, 2, 3.5. And then 3, 3.25. Say again. This is going to be an exponential. And I think it was even KK who said, hey, I think this would be a decay, right?
Can I talk to you outside right quick?
Sure. Everybody needs to have their graph done by the time I come back inside. Now, be careful because this needs to be what shape?
Exponential.
Exponential curve. So look at it, make sure that's happening. Good. Quickly, then put it back up. Alright. Now, what I need us to notice to help us accurately graph this. Right. Well, I'm just going to help you
That's a decay.
notice a detail about this graph.
It's a decay.
I mean, is it decreasing?
Yeah.
Yeah, okay. So, thinking about this decay right here,
Yeah.
what y value are we starting to approach that we're probably not going to pass?
The first one,
We're past the 4, what are we getting closer to?
Let's see.
0.
Not going to get to 0.
We ain't close to where we were
Infinity.
Guys, look what number are we starting to get close to.
4, 3.
Right.
We're getting close to 3, aren't we?
Yeah.
The next point, I'm going to have to check myself 100%, but I believe the next one would be a 3 point...
3.
Actually, hold on, let me check. Let me think about this. It'd be a 1/8, yeah, 3.125.
How you do this?
Because what I know is the pattern of this is a 1/2 plus 3, a 1/4 plus 3, a 1/8 plus 3, because what am I repeatedly doing? Multiplying by 1/2, right? And then adding 3 to it. And so I'm just getting that decimal. Notice I keep it going. What number is that y getting closer and closer to? Is it?
The nigga ain't said
Keep getting smaller,
It does keep getting smaller.
so eventually it's gonna hit zero.
Is it?
I don't know.
Look right here. Hey, I need y'all to pay attention to this. This is getting closer and closer to what? 0. But then what are we doing? We are adding. So if I have 0 and then I add 3 to it, what am I going to get close to? 3. So I'm going to go to y equals 3 and I'm going to draw a horizontal line. This is what it's getting close to. By the way, what am I going to call that line that it's getting close to? Say it louder. It is horizontal. I was looking for a different word.
The T word.
Not a T word.
Oppose.
Asymptote, right? That A word that we
What did
learned
that?
yesterday?
What did
I
that?
didn't learn that.
Oh, yesterday. I was here yesterday.
Okay, we learned it yesterday. It's an
It's
asymptote.
for the impact.
Notice, does anyone remember what our asymptote was before?
The
It was
BV.
y equals
Big V.
0, but what did we just do to this? We translated it
The 3.
up 3. So it was 0, but we translated it up 3, so
3.
now it's y equals
3.
3. Okay, so we're going to talk about this more. Draw your exponential in there. Notice it's got to be that exponential curve, exponential decay, and that's why I want that asymptote in there. Okay? Now, yes, Chandler. It's because I'm repeatedly multiplying by 1/2, that's my base. So 1/2 times 1/2 is 1/4, 1/4 times 1/2 is 1/8, 1/8 times 1/2 is 1/16.
Ew.
And so if you multiply by 1/2, 1 times 1, and then 2 times 2. That's why I got 1/4.
That's what that expansion means.
An exponential, whatever my base to a power is, that's what I'm repeatedly multiplying by. And then afterwards, I'm going to add 3 every single time. What? What is, I need better one.
1/2. They're adding for.
Right here? That's this.
Yeah, but we have to do that.
No, I'm explaining where these numbers are coming from. You literally asked, how am I getting these numbers? It's because I have these as the 1/2 to a power, and I'm adding 3 to it. Well, it's an exponential function. It goes from negative infinity to infinity. Okay? We can talk more about it in a second. But there's my exponential function. Now, without even knowing the equation, you can get the logarithm, the logarithmic function. What could I do to get the logarithmic function of this exponential?
Transpose.
Transpose my what?
What you call
X and
it?
Y.
The x and the y, the inputs and outputs. By the way, I should have put g of x here. Because now,
Yeah. Now you can just do 7, -1.
and so that's what we would want. And notice I'm gonna, this Chandler is the big reason why I did g of x, so that now I can use this notation, because when I have that superscript in -1, what does that mean? It's the inverse. Well, the inverse means that we would have transposed, right? So -1, 7 becomes 7, -1. Then 5, 0. 4, 1. 3.5, 2.
3.253. And so on and so forth.
Yep. And so now I can graph those points. Notice at this point, what is my x getting close to?
4.
Is it?
You're going down because of 0.
What did this y value get close to? 3. So what is this x value getting close to?
3.
So notice where I'm going to go to my x equals 3, and I'm going to draw what kind of line?
3. Oh, exponential line.
On the visible line.
Guys, this was
Interval.
horizontal,
Oh, vertical.
so this is, the inverse is going to be vertical.
They're right though.
He is 100% right.
Yeah.
Remember,
I don't know.
with an inverse, the inputs become the outputs, right?
Yep.
Transpose, right?
It's our ski.
So for inverse, right, that log function the asymptote is now vertical. The asymptote was originally horizontal, now it's vertical, because what happened to my inputs and outputs? They
Switch.
transpose. Make sure, Dewan, you're prepared to use the proper math term of transpose.
Yeah.
You can explain it as the inputs and outputs are switching, but the term is transpose. No, I mean, it's okay, I just want us to be careful and update our language for the mathematical sense here. Now we just use that to graph. So 3.125, 1, 2, 3, 4. And so just graph your points now. 3.25, 3. 3.52. That's a little too far.
Where's this the reflection line go?
Well, what line do we always reflect across? Y equals x. So if you wanted to draw y equals x in here, you can, but that has never changed and never will. The reflection line is always y equals x. Where'd all my markers go, guys? So gentlemen, my reflection line is my reflection line. For an inverse function, we always reflect across y equals x. Okay. 5, 0, and 7, -1. Notice that is a reflection across, maybe not perfect, but is a reflection across this line. I think that's right. Yeah, that's correct. Just looks a little off.
I write all this?
No, I'm just writing it for my own amusement.
Oh, okay.
So, I think someone asked the question, how do you graph a log function?
Yeah.
What's the answer?
You graph.
What did we do though to graph this log function?
Transposing.
We transpose our inputs and outputs. This is why we covered inverse functions originally. I will not ask you to graph a log function without the original exponential. Okay? So, notice once again, what do I recommend creating to help you with the graphs?
A table.
Table, right? Those tables help us stay organized. Be careful, make sure that you have your correct asymptote, because isn't this supposed to be going up at 3? But 3.52. So 3.52 would be here. 3.253 would be here. Oh, hold on. You've got to put your numbers on the lines. Okay, but I'm trying to help you make sure you do it right. Notice it should be here. Hey guys, really quickly, because this is important. I guess I don't talk about this. We should know this. We always write our numbers on the intersect or on the lines, because the whole idea is what's the number right here at the center?
The 0.
0. And how far have I gone to the right to this line?
2, 1.
1. That's why the 1 is at the line.
Yeah.
And then at this line, how far have I gone to the right?
2.
So you do not put your numbers in the middle of those spaces. You put them
Put it
at the
at the
lines.
space.
You have to make sure you put your numbers at the lines, otherwise things get wonky and they get off.
So if I got 2, I put it at 2.
Yeah, we don't want that. We want to be accurate. So notice, that's why my curve looks like this. If you don't do that, things will get off. All right. So once again, to wrap that up, how do we graph logarithmic functions?
2s.
Transposing our
Inputs,
Inputs and
outputs.
outputs. Simone, you with us?
You got it?
Okay.
Come on, Shimon.
So, do you have to have a table? Jaden, do you have to have a table to do that?
No.
No, but is it helpful?
Yep.
It very clearly lays out those points.
There we go.
What you had before?
That's so scary.
Oh, yeah.
What you gonna get?
Oh,
What you gonna give me, bro? Because you know, don't do-
thank you for sharing with me. Appreciate you checking out your food.
Every time I got something I want, I do.
Office,
Hey, can I get the nurse to come up to 403 quickly, please?
did you say the nurse?
Yes, please.
Okay, I'm sending her.
Thank you. Alright. So, our inputs and outputs are transposing. We need to recognize that. And we can do that graphically or tabularly. You just have to have those points. And we have to know how to graph those points.
Yeah.
As long as we have points and we can graph it, we're good. Do notice what line helps us graph our logarithms and our exponentials?
Exponential lines. Wait, what?
I
Oh,
was
vertical
thinking
line.
vertex line.
Wait, what?
Or is it the horizontal?
The
Horizontal.
horizontal, but what's that called?
Horizontal.
Asymptote, right? Those asymptotes help us graph those. Because it approaches that asymptote as at an infinity, right? So,
Yo. Isotopes.
to help.
Can you explain what that word means one more time, please?
Did you write it in your pages, in your notes?
I don't think he was here.
I wasn't here, brother.
My bad. You right.
So like,
So, do you see how this curve is approaching that line
yeah,
as it goes up to infinity?
Yeah.
Do you see how this curve is approaching this line as it goes out to infinity? So
basically,
what an asymptote is, it is a line
they intersect.
or curve,
Could they?
a function approaches at an infinity.
See, I was a little bit right. So like that.
Okay? So notice, does it intersect it though? Does it get there?
Oh, no,
No, it is only approaching it.
I bet that.
Okay? So we need to recognize that. It's a line or a curve, a function approaches at an infinity. Okay, so people were asking about our features. Notice I did this function in particular to help us talk about features a little bit more clearly. So I would move to the right-hand side of that Freire model where it literally talks about what? Features, right? So let's look at the features of my exponential. All right, Trey, when I say domain, what do I mean by that? Very close.
You said what
Not
the
x-intercepts,
The Y.
It's
all
a
the
Y.
x-values. Remember, the x-axis is this line, but I'm not looking at the x-axis, I'm looking at the
X-values.
x-values based on that, right? And so what do we always write first when we do our interval notation? A
minimum
Minimum and maximum.
minimum and
max.
then a
The mo-
max, right? The table helps me graph. Say again.
The max. No, the man and man. Whatever. It's the minimum and the maximum.
You can grab that stuff for you. Finish it up.
Are we writing this right here?
Where it talks about features on the graphic organizer. That's where I would put it. Make sure you go to the reference to
Pull me up.
note the reference to that graph. Okay? So Minimum. What is my minimum x value for this exponential curve here? I would say the x, right? We gotta remember x. So it starts to the left and moves to the right. That arrow, does it ever stop? So it's always going up and always going
Down.
left.
Left.
Domain, we need to recognize is negative infinity. And does it ever quit going to the right?
No.
So the maximum is
Negative. Positive.
positive infinity. Right? And again, am I ever going to ask for these features without the graph?
No.
No, I just need you to be able to know what I mean by domain, look at the graph and say what is my minimum x and what is my maximum x. Yes, Dewan.
I'm saying though, like when we did the what's called demonstrated understanding on that, I could have swore I did that and got an LE. So
Well, I'm going to go out on a limb and say you didn't.
Ooh. Take that off your set, boy. Take that off your set, boy.
said what?
Take that off your set.
Range, ladies and gentlemen, range.
One ain't got none.
Minimum Y and maximum Y.
All right, so minimum y. So I'm gonna start at the bottom, right? And I'm gonna come up. Tell me when I start to get to y values.
Right here.
Right here, at the asymptote, right? Now, do I actually get to that 3? No, right? That's an asymptote. I'm approaching it. So I don't use a bracket this time. I use a parenthesis. And then what's the maximum y?
Negative 50.
It keeps going up. Remember, Dewan, when we talk about y, it's up and down.
Negative.
No, it's going up, my
I
guy.
said regular infinity.
Okay, say again. Bottom right, yep, where it says features, doesn't it? All right. So there's my domain, my range. So I got a minimum and I have a maximum. For right now, I'm going to skip intercepts, but intercepts are a feature we need to be able to look at. Okay?
So we do that twice because it's two things.
Well, there's always x and y, domain and range.
I'm talking about for
We'll do the inverse in a second. Yes. Okay. I'm going to skip intercepts right now. I'm going to, so intercepts, that's a feature we usually want. Intervals of increase and decrease we usually want. But we're going to skip both of those for now for time. What I am going to do right now is this. Does anyone remember what I highly recommend you identifying before we do the asymptotes?
Nope.
The end behavior.
The end behavior. We always want the what?
End behavior.
End behavior. All right, so let's do end behavior. And how many, tell me this, let's see, oh, Janai, not feeling good? Kyson, how many ends does every graph have?
How many?
Ends.
2.
How many?
2.
Why?
Because
Can you come circle the 2 for me for the exponential?
I believe they're on the x and y axis though.
Man.
Uh-oh.
Okay, so I need us to pay attention to this. Circle the ends. Literally, where do we see the ends? At the
End.
At the arrows, guys.
At the end.
Those are the ends, right? Did you see that, Kyson? Instead of looking at the back, you saw me circle?
Okay.
So, left hand end behavior. Just gotta know our left from our right. When I look at this left hand end behavior, what is my x approaching? We gotta be careful. X, right? That's which direction?
Left,
Left
right.
and right.
Left, right.
So is this going, is it going to the right? It's going to the left, which means x is going towards? Negative infinity. As x goes to negative infinity, what is y going towards?
Positive infinity.
It's also going up, right? So you can draw little arrows to help you see it. Left and up. Right hand end behavior.
But I can't see.
I can't
Gotta have both ends.
I can't see.
Then move up here. I got a few spaces that you can move to. Or do you just want to complain?
No, you that's in the.
We're gonna bite in the way.
Gotcha. Right hand end behavior then. On the right hand side of the graph, what is x going towards?
Positive infinity.
And what is y going towards?
Negative.
0.
Is it going to 0?
No, negative.
Remember, we drew this line because what's the y approaching, getting closer and closer to?
Negative.
3. Remember, those exponential, look guys, those exponential flatten out, don't they?
Uh-huh.
Uh-huh. Those exponential flatten out, and it approaches that 3.
And why is it 3? on the graph, not on the table.
It is. I just can't notice 3.5, 3.25, 3.125, 3.0625. The next one would be 3.03125.
Well, I can
I'm just saying, like, how you know it's 3 without looking at the table. Like,
I use that table to help me graph it. But the other thing is looking at the equation. You see that plus 3 right there? That plus 3 told me that, remember, originally it approached the x-axis, right? The y equals 0. Because of that plus 3, it's been translated up 3.
I ain't going outside.
Okay. You know with that?
yeah.
Something like that.
Now again, so one thing to be aware of, council, and I said this earlier, because of the time that we have, I'm going to give you the table. Okay? I'll give you a table to use to help you, of the exponential, for you to get the logarithm, to get all these features, things like that. Okay? Alright. Questions about that end behavior?
Yeah, just
You
don't.
see, you're over there, table.
I'll give you the exponential table.
Just don't erase it.
Not the logarithmic table, but the exponential table for you to identify those features, things like that.
So the logarithmic, just the inverse of that.
So the inverse of an exponential is a
So that one.
logarithm. We're going to talk about it more in a second.
True.
So we have to do the inverse, we have to do the logarithm graph by ourselves.
Yes.
Table by ourselves.
Yes.
Somebody teach me.
Both. What do we know about the relationship between an exponential and a logarithm? They are,
The same.
nope.
They're the same.
Transpose.
The
opposite of the
inputs and
same.
outputs transfer
Transpose.
because what's the relationship between those
They
functions?
different.
They are, it starts with an I.
Inverse.
Inverse.
Inverses.
You could say that instead of just looking at me and saying.
Bruh,
Okay,
I ain't gotta say nothing. You know I know it. With you?
council.
My bad. Go ahead, teach.
Now that I have my end behaviors, what can I easily identify? Asymptote. Which we actually talked about it earlier to help graph it, but where do we see a value that the function approaches at an infinity? Is this approaching a value?
No, it's
No.
approaching 3.
So y is approaching 3. So my asymptote is y equals 3. It's the value that one of the ends is approaching. It's the value that one of the ends is approaching. You told me you were going to stay awake and take notes. I need to get you
Uh-oh.
Alright.
You said value one of
Still
the.
can, still can.
Correct.
Good.
It's the value that one of the
Are you
ends
okay?
is approaching right here. As x goes to this infinity, y is going towards 3. So remember how it's a value or a function that, or it's a line or curve the function approaches at an infinity.
Alright, so.
Okay, so we got all these notes down?
No, sir. Not at all.
I knew everything before we did though, so.
I got mostly graph.
You was in the weight. You was in the mate. You was in the weight most of the time.
Go on.
I'm just being real with you, kid.
No, you ain't being real. You're not being real with yourself.
Ooh, kill him.
Shut your dick.
Kill him.
Enjoying.
You look, I can't
Kill
say
him.
I mean, what?
Focus.
Focus.
Yo,
You're the one who said that you haven't had time, and then you're sitting here talking.
When I said I ain't had time.
Just talk it back.
What you talking about? When I said that? When that came out of my mouth, Mr. King?
Just stop, please stop.
Please, just give it up.
Sorry, you didn't say those exact words. You said that I've been in the way, so you haven't had time.
Barbecue.
So,
Why you eat, bro?
what I would remind you of is, without even looking at the graph, because I understand inverse functions, I already know the domain and range.
Facts.
What would the domain of this logarithmic function be?
Infinity, name infinity. No, wait. You said what? Domain?
Domain.
3 infinity.
Why is it 3 to infinity?
Because they swap.
What was my outputs becomes my inputs. So that domain has to be 3 to infinity. You can even just say that it's those inputs and outputs are transposing the value, the features are switching. So then what would have to be my range?
Neck, pen. I got range, Mr. King.
Fair enough. We can actually check it. Is my lowest x value 3?
Yes.
Does it ever quit going to the right?
No.
No. For my range, is my lowest y value negative infinity? Does it keep going down for forever?
Yes.
Does it ever quit going up?
No.
So is my range negative infinity to infinity?
Correct.
Correct.
Yep.
Yep.
Got it.
Now, the end behaviors slightly change, but only slightly. Got my left-hand end behavior. When I look at the left-hand side, what is x approaching? The x? It does keep going up, but up is that x or y? That's y. Look again at my end behaviors. What is x going towards?
3.
X is going towards 3 now, isn't it?
Yeah.
So as x goes to 3, y goes towards infinity. So the left and right hand side switched. It doesn't always, but notice how this x and this y did switch, right? So x goes to 3, y goes to infinity.
Ooh, Lord.
Ooh, Lord.
Well, I was about to die.
You really
Okay.
think
How would you compare it?
No, please say like
I mean, yeah, but Pierce.
a lot to take in.
So there's my end behaviors, and so my asymptote
How you feel that? Asymptote? Oh, there you go.
is x equals 3. Because the x is approaching 3.
I hate that word with Pat.
I'm sorry,
See it.
it's a mathematical term that you gotta know.
Asymptote.
Asymptote.
Huh?
Asymptote.
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 Sound like a cure.
Asymptote.
Secure.
Dang.
They do.
What are you talking about?
You looking, Ken looking at me. Something would happen to you.
Oh, yeah.
Oh.
Okay, before we continue, with our questions, what can I clarify?
If we did all of this on this paper, we would be able to.
Is there a problem?
As long as you reference it on your
With
prayer
the
model.
exponential reflection be on the test.
The what?
The
Exponential reflection, she said.
That's what that logarithmic purple function is.
Right?
Right?
Yeah.
The reflection across the line, y equals x, was when we reflect across y equals x, what kind of function does that give us?
Exponential.
Well, no. It doesn't matter what function I start with. What is reflection across y equals x give me? It starts with an I. Inverse function, right? So the inverse of the exponential, isn't that what this whole purple section is all about?
Yep.
That's it.
Yeah.
Well, why are you freaking out? Like, oh, Mr. Kinney, you didn't tell me that.
Right. You see it.
She got issues.
Crash out. Oh.
I got the receipts. I got a video that you can see it.
Wait, what was the
I'm a
question?
strong.
She was asking on the board over there, could you explain the exponential reflection? All right, have I answered all the questions? I think so. Sir,
I use the restroom real quick.
better run like the wind because we're about to cover the last little bit for these functions. Okay, can I erase this brown section for the original exponential function?
Yes.
No.
So you got it all? Ariana, you got all you need?
If it take you a long time,
No, it's gonna take you a while.
It didn't take me that long. Okay, go. You guys are
When's last day of school?
Friday, we got exams Monday, Tuesday.
When we gonna start reviewing?
Well, we're starting reviewing on Thursday.
Okay, that's a good thing.
So like Friday, half?
Yep.
We start reviewing tomorrow. But I don't know.
All right,
We learning new stuff tomorrow, bro?
no, but unless we don't get, yes, if I can get through this today. So, please notice, this is the proficiency scale on inverse functions, restricting domain. Remember I took out composing two functions, determining if two functions are,
Oh. Keep talking. Hey. Man, you keep talking, I'm missing.
Which one is
Determining if two functions are inverses graphically. This is the inverse functions one. Graph the inverse. If you're given a function graphically or tabularly, solve an equation for the input to determine the inverse. These are all the things we did on demonstrate understanding. Most of these things we've done today as well, identifying features of functions and their inverses. And so Cam, one thing I would point out is we actually have been naturally reviewing while getting new content because we're basing all the exponentials, or all the logarithmic stuff off of exponentials and inverses. So there's all that. By the way, this exponential, was it 1-to-1?
Yo.
Get ready to go. Oh.
You don't understand 1-to-1?
Yeah.
Okay, so what does it mean to be 1-to-1?
One input to one output.
One input to one output and one output
To
To one
to one input. And so remember, it just passes the horizontal line test and the vertical line test. If
Gotcha.
it passes both horizontal and vertical line tests, it's a 1-to-1 function.
I knew it a little bit.
So now we're looking at logarithms. Do we know what a logarithm is?
Inverse exponential.
It is the inverse of an exponential. There's something else I said at the beginning of class. It is an, say it, it's an exponent, right? If I give you log base 2 of 8,
4,
not 4,
2,
not 2,
3.
why 3? And 3 out of 8. But why? Because 2, so 2 to the third is, what is a logarithm? It is simply an exponent.
1, 2, 3,
It is an exponent. Okay, guys, eyes and ears up here so we can learn something and not ask me to stop every 5 seconds so that we can focus. Evaluate logarithms with integer exponents, right? Because a logarithm is a what? Exponent. We are not, we're not going to estimate. I'm going to let y'all use calculators to do calculations of logarithms.
Yay.
Of other exponents. Rewriting exponentials as logarithmic, we're going to do some of that today. We've already solved some exponential equations, and it's as complicated as it's going to get. I will point out, you can take out properties of logarithms, you can take out transformations and Euler's number, and the natural logarithm.
Can I?
We don't have time for it.
Can I pick up?
Okay?
Argument.
But the other things we have either covered or are about to talk more about. Sean and Julian,
Kaiser.
stop talking while I'm trying to teach.
Kaiser, get
What's up? Like, Sean, do you have a question?
Yeah.
Oh. We got that everything you looking at right now.
Yes, it is a purple proficiency scale that I passed out yesterday or Friday. Friday, I think.
Can you give us a good example of the
I
log
was here
thing?
yesterday.
I know. That's what
Which
y'all
log
had.
thing?
Where you write log and you gotta actually do. We need a good example.
May I have one?
Hold on. You need to read. Can you say your question again?
Okay, you see where you spelled out log, not just saying it? L-O-G?
L-O-G.
Like, say what this is.
Like, give us a good,
Definition.
yes.
So if you have your textbook in pages, we already did all that, and turn to page 127. So textbook pages M3-127. Do you need one as well?
Hey, which one of you do this again?
Mr. Can
Yeah.
I get some water?
Which one?
I know. Des need one too. I'm coming. Dewan. Say it again.
Which one of you do this?
We've done several of these, but remember, you only check it off if you know what it means. Page M3-127.
What's a natural logarithm?
I just told you we're not doing that one. Don't sweat it. It deals with what's called the number E or Euler's number, but we're not going to cover that partially because we don't have time.
It's a number-
secondly, 'cause
it's a number-
actually a pre-cal.
It's the number E like.
Say it again.
We're not there.
Some of us may not be, but
Yeah,
the
I
number-
ain't.
guys, okay, chill. Dewan, what's your question?
It's the number E like the number I.
It's not imaginary. It's closer to the number pi. Like pi is an irrational 3.14159, yada yada yada. E is the number 2.71828, yada yada yada. It's an irrational number. Good news is he ain't.
Oh.
So logarithm. What?
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 Do a stretch out comment logarithm.
No,
What is that?
I'm about to show you.
No.
Thank you.
Okay, what about argument?
No. We gotta talk about it.
I know
What you trying to do right now?
No.
Come on. So a logarithm of a number is simply the what?
I don't know.
Logarithm.
The logarithm of a number is simply the what?
The exponent to which
Thank
the-
you. Even if I hadn't, been pointing at it in the textbook, we talked about a logarithm is a what?
I said the exponent.
Exponent. The whole day, right? From the beginning of class. So, it is the exponent to which the base must be raised to produce the number.
You should see your face.
And so, here is an example where log base 2, and that's how you would read it, log base 2 of what?
3. Oh, 8.
Of 8. So you read it as log base
That's wrong.
2 of 8 equals 3. Or is 3. That's how you would read that.
So that means.
And the argument, another way to read argument is just the input. That is literally what the word argument means. I did not learn that until 2 years ago, I think.
And it's the answer.
No ma'am.
It is the answer.
No ma'am. We don't just say answer. It is the exponent or it is the value. Notice the logarithm is the exponent.
And what does that mean?
What do you mean?
Like, that, okay, log base 2 of 8 equals 3. And?
So, if I were to just give you log base 2 of 8, what are you looking for? And
The exponent.
the exponent. What is that exponent?
3.
3. It's just like saying the square root of 16. What is the square root of 16?
4.
So it's the same as saying that, but in this case, I was looking for the base to get 16. Here, I'm looking for the exponent.
Can you give us one of them so we can write logs or something by ourselves?
Yes. Let's look at
Don't give us a big number.
the very next page. Nope, we're gonna skip that one.
You were about 10,000.
No. Page, there's number 2 within that same set of information.
What page on?
Page 2. Except in this one right now, we're taking a logarithm. Yep, number 2, page 129. We're taking a logarithm and writing it as an exponential. You want me to do this first one with you? You want to try it on your own, Cam? Dewan, have you taken 30 seconds trying to figure out how to write that as an exponential?
I ain't even saying nothing, bro.
Dog, you were just talking. I watched it. I heard it.
He was helping me get rid of my
Okay. Have you thought about this question regardless?
No.
I need you to at least try to rewrite that logarithm as an exponential.
I want the bottom.
The one at the top, number 2.
Right there. Right there.
I bet it's 2.
129.
It's 3. I bet.
You bet. So notice all I'm asking you to do is rewrite it as an exponential. Yes, ma'am.
What? You saying?
Do it quickly. We got 8.5 minutes left of class. No. Hey, not typing into a calculator. Read the directions. Rewrite in what?
I got me a light.
129.
Got me a soul.
So,
I found it.
okay. We're trying to rewrite this as what? Hey, KK, what you doing over there?
Yeah.
Focus. What am I trying to rewrite this as? In what form?
Exponential form.
Exponential. So, what would be the base of my exponential form? It's still base 10. What is my exponent?
X.
Remember, a logarithm is equal to an
X.
exponent. So base, so 10 raised to the x is equal to 1,000.
You don't get my B's and take
1,000.
And so Cam, you already said you thought that the x was what?
3.
X was 3.
I got 2.
See? Ooh.
Type 10 to the second into that calculator.
That's 100, ain't it?
So notice 10 to the third is equal to 1,000.
Oh,
So x is equal to 3.
I put 100.
I ain't got it. I ain't got this shit, man.
Yeah, never mind. I put
What did you say, KK?
Huh?
What word did you just use?
I told him I ain't got it.
Got what?
I don't know what you're talking about.
You used another word in there, didn't
You
you?
better tell them.
Come on, man.
I ain't got nothing.
Better tell them Andy up when you real.
Did you not? We should have torn this out of the textbook last Friday. You didn't. We need to get it after class. So, with all that in mind,
So you hit me, my boy.
how am I going to rewrite B here?
5 to
Put your way, bitch.
5 raised to, what's my exponent?
X. 5, I mean.
I was
You said
saying
what
the-
happened?
The logarithm is equal to an exponent. So 5 to the 5th is equal to
X.
x. And I can just type that into the calculator. I believe it's 6,000. No,
It's 5,000.
3,125.
3,570.
It's what? Thank you. So notice I can rewrite my logarithms as exponential expressions and vice versa to help me out.
No cheers there.
So how would I write C? What would be my base for C?
It's
What would be my exponent?
1.
And that's equal to?
2.
So remember, base and exponent. If you can remember what the base and what the exponent are, everything else falls into place. Say again.
Huge now.
What's x to the first? Helps you on the right page, right? 129?
It's gonna be on me in a minute. I'm gonna take them off you. I'm gonna take your life.
Okay.
I'm talking like that.
So,
Heard I said.
to focus on some key ideas,
Allen in the office for just a moment, please.
he's on his way.
Yeah, they need the one other for.
I don't know.
Big collar.
Dude, just grab the volume 2 book and look for it.
Big collar.
Oh, it's chill.
If it's not in one of those, then it's in one of these. Alright, yo, fix yourselves. KK, give him his crap back.
Give my crap back.
Like, we're juniors in high school. Why are we acting like 6th graders? I don't teach 6th grade for a reason.
For a reason, KK.
These kids won't get half of this crap.
I'm sorry. I'm sorry, Mr. King. Man.
So, Cam, you were asking about a common logarithm earlier. All that we mean by a common logarithm is a logarithm with what base? 10. Okay? If you are ever given a common logarithm as a log base 10, and this is known as the common logarithm, you remember how with a square root, do we actually write the index with a square root?
No.
But it's understood to be what index? 2. With a common logarithm, I don't write the base, but it's understood to be what base? Base 10. You good over there?
She got real bad hiccups.
I can tell.
Oh,
Okay. So that's just a small detail, a small fact. Okay. One thing I would do if I were you tonight to help you prepare for your demonstrated understanding tomorrow is I would do the graph on number 1, or the graph on page 129. I would do that to prepare for your demonstrated understanding. You can also do that one problem just attempted during advisory. Hey guys, I still have 3 minutes and I gotta cover one more thing. I'm just trying to show you what I would do to prepare for a demonstrated understanding tomorrow. So, graph on M3-129. What page is this? I would do the features on M3-134. Use stop packing. Have your sheets out to make some notes right now.